In this video, we're gonna see how to create chat PDF using Python. That is, you can upload any document and interact with it, and you can ask any questions, and you will get the response appropriately from the document. It can be either the PDF or the document Word file. For this, we're gonna use the Gemini API, and the cool part here is that we're gonna build this in less than 10 lines of Python code. So this is the demo of what we're gonna do in this video. Here you can see this is the sample PDF that we're gonna use in this video. This is just a sample research paper. So we're gonna upload the sample research paper and we're gonna interact with it. You can ask any prompt about this PDF. You can ask any questions that you have from this research paper and you will get the response immediately. Here you can see I have uploaded the sample report paper to this chat PDF. And for the first prompt, I ask what is the methodology used here. You can see that we get the response. Here we use the OCR based answer extraction and then question answer mapping and the LLM based answer evaluation. And finally, we use the grading and score assignment. This is what we have in the methodology report PDF also. You can see that in the PDF also we have the OCR based answer extraction, NLP based evaluation and the question answer mapping. And the cool part here is that it will return us the answer in a markdown format. That is, you can just copy the text and you can go to any online markdown compiler and you can paste the text and you will get the report in a nice format. You can see that here on the preview section, you can see how the result is in a nice format, that is the bullet format, and each heading is highlighted. So this is another benefit of using the Gemini API. And for the next prompt, I ask what are the specifications we use here. You can say we get processor Intel Core i7, RAM 16 GB, storage 512. This is same thing that we have in the PDF that you can see in the background that I have opened the PDF. In the PDF also we have the processor Intel i7, RAM 16 GB, storage 512. So let us see how to build this chat PDF in less than 10 lines of Python code using the Gemini API. Let's get started. For this, we have Gemini API. First, we need to get that. To do that, just open your browser and type studio, that is the aistudio.google.com. Just head over to that website, aistudio.google.com. Make sure you log in using your Gmail credentials in this AI Studio. You can see that this is the dashboard. You can see get API key. Just click on that. And in the below, you can see option called the create API key. You can see that I have already have a API key. So let me create a new one. So let's select the Gemini API project and let's click on create API now. You can see that it is generating the API key for us. Let me copy this API key. Now we have the API key, right? Let's create our project folder now. Let me go to the desktop and let's create a project folder in the desktop now. Let me create a folder now. Folder name will be chat PDF. Let's also open this folder in the Visual Studio Code also. Let me open this folder in the Visual Studio. Now I have opened the folder in the Visual Studio Code, right? Let's create a Python file now. The file name will be main.py and let's paste our API key here. So this is the project folder that we're gonna use through this video. Let me paste the API key here. API key equal to, this will be our API key. Now we have the API key, right? Then we can start installing the necessary libraries that we need for this video. Let me open the terminal. If you are using Windows, open your command prompt. I am using the Linux, so let me open the terminal and just type pip install and we're gonna use the Langchain here. Langchain or Google AI. Langchain, Google Gen AI, and also we need the Langchain and press enter. You can see the requirement already satisfied. Let me clear the screen and then we're gonna install the pip install Fires. So this is the vector database to store the embeddings. So Fires CPU, and we also need the PyPDF and we need the sentence transformers. So sentence transformer is used to create the actual embeddings. So Fires is used to store the vectors database, that is the embeddings, and we're gonna use the sentence transformers to create the actual embeddings. Now we have installed all the required dependencies, right? Let me close this. And before we proceed ahead, we need a PDF, right? So this is the PDF that we're gonna use in this video. Let me open this PDF. This is just a sample research paper that we're gonna use in this video. You can see that this is just a sample research paper on AI evaluation using the LLM and the OCR technology. Let's see if we can successfully interact with it. So let me copy this PDF and let's paste it into our project folder now. You can see that now we have the Python file and the PDF in the same location. Make sure you have both the files in the same location. Let's close this PDF now. This is the PDF that we're gonna use in this video. Just a sample research paper. Let me close this. And now let's import all the dependencies that we need in this video. So from the Langchain document loader, so we're gonna import the PyPDF loader. And from Langchain embeddings, we're gonna import the Hugging Face embeddings. So we're gonna use the Hugging Face embeddings to convert the normal text into a numerical representation. So embeddings actually means turning normal text into a numerical representation. So we're gonna use the Hugging Face embeddings. Then from the Langchain google-generativeai, we're gonna import the google-generative AI, and finally from Langchain, we're gonna import the fires. So we're gonna use the fires database to store the embeddings. So that's it. These are the necessary libraries that we need for this video. Actually, the files is located inside the Langchain.vextra stores. Let's import the files now. So that's it. Let's import the PDF now. PDF file equal to, we're gonna load the PDF file now. To do that, just call the PyPDF loader, and inside that you'll have to provide the PDF part where the PDF is located. You can see that here we have the PDF. Let me rename this PDF because this PDF contains spaces. Make sure you don't have any spaces. Use the underscore if you want. So let me rename this to sample report. So sample report.pdf. Now we have the PDF file, right? We can create the pages. That is, we can extract the individual pages. So pages equal to PDF file dot load and split. We're gonna convert the full PDF into a collection of chunks. We're gonna turn this into a blocks of text. So and we're gonna store this in a pages variable. This will return as a individual pages, and we're gonna store this in the pages now. Now we have loaded the PDF, right? Let me show you the actual workflow of this chat PDF. You can see that this is the workflow that we're gonna use in this video. First, we get the PDF from the user. That is, we have defined the PDF, right? And we're gonna turn the PDF into a vector store. That is, we're gonna turn the PDF into embeddings. Embeddings actually means turning the text into a numerical representation. So once we have the numerical representation, we can easily search. If you have the text in a numerical form, we can easily search for a element using the similarity search. So similarity search is powerful when we have the text in a numerical form. That's why we are converting the full document in the embeddings. To store the embeddings, we're going to use a database called the fires database. After we have stored the embeddings in a vector store, we're going to ask the question from the user. You can say that we ask the question from the user, and once we ask the question, we're going to convert the question into a embeddings also. Then we're going to search the query into the vector store using the similarity search. If you found a match, it will return all the text that contains the query. And once we have all the details that has the user input, and we're going to pass it to the any LLM. That is, here in this video we're going to use the Gemini. If you want to use the OpenAI, you can also use that. And finally we will get the response. So let me recap this one more time. We're going to use the vector store in this video. That is, we're going to convert the actual PDF in here embeddings, that is the numerical representation of the text, and we're going to store this into a fires database. That is the database that is used to store the embeddings. So once we store the PDF into a embeddings form, and we're going to ask the question from the user, and we're going to use the similarity search to search for the keyword in the vector store. Once we got a match, it will return us the series of text that contains the keyword, and we're going to pass that result into a Gemini or any LLM, and we're going to get the fine-tuned response. So this is what we're going to do in this video. So let me go to the Visual Studio Code now. Now we have completed the PDF load, right? We need to work on the vector store. To do that, we're going to use the Hugging Face embeddings. First, let's load the embeddings now. Embeddings equal to, we're going to load the model first. So this will be embeddings equal to, in this video, we're going to use the Hugging Face embeddings to convert the text into a numerical representation. So Hugging Face embeddings, inside that pass the model name equal to the model that we're going to use in this video, all mini LM, and the version number is the L6V. So that's it. This is the model that we're going to use in this video. Using this embeddings model, we're going to convert the text into a numerical form. Now we have the model, right? We can store the model with the pages now. So database equal to fires. We're going to use the fires database, fires dot from documents. Here inside these documents, we're going to pass the pages, that is the text, and the model that we are using, that is the embeddings. So pages, this is the actual text that contains the sample report. So pages, and the model that we're going to use is these embeddings models that we are defined here. So this will be embeddings. Now we have stored the text in a numerical form, right? That is DB. We have completed this step, vector store. We're gonna then ask the question from the user. So query equal to, this will be input function, and inside it enter the query. So that's it, and we're gonna search it using the similarity search. So docs equal to db dot similarity search. We can search the similarity between the two texts, that is the query and the embeddings that is stored in the FIS database. So db dot similarity search, inside that pass your query, that is the user query. Now we have the response, right? We can consider now we have completed this, and we're gonna search it in the vectors database also. Then we will have to pass the response into the any LLM to get the fine-tuned response. Let's do that now. Here you can see this is the result that we got from the vector store for the query that we provided. You can see that this is the sample PDF. If you ask any question, right, what are the methodology used here, it will return all the uh, text that contains the keyword methodology. So this is the power of using the embeddings. The docs will contain all the similarity keywords. So we're gonna pass this keyword to the LLM, right? In this case, we're gonna use the Gemini LLM. So inside this relevant answers, so docs will contain the relevant search. So relevant search, we're gonna convert all the relevant search into a string now. Actually, the docs is in the list format. We're gonna convert this into a string format. So I'm gonna use the join function, and inside this we're gonna use the list comprehension x dot page content for x in docs. So that's it. Now the relevant search will contain all the text relevant to the query, user query. So once we have the relevant search, we can define a Gemini prompt. So Gemini prompt equal to, we're gonna give you a prompt like, use the following context as a reference to answer the question. If you don't know the answer, just say don't know, but don't make it up. So this is the prompt that we're gonna use for the Gemini. If you don't know the answer, just say don't know, don't make it up. So that's it. This is the prompt, and let's convert the actual prompt and the relevant search into a input prompt equal to, first we're gonna pass the uh, Gemini prompt, and then we're gonna pass the context, that is the relevant search. So let's also pass the relevant search. You can see this is the relevant search that contains all the similarities for the user query, and finally we will pass the user question. So user question, we're gonna pass the query now. Now we have the input prompt, we're gonna invoke the LLM, right? So LLM equal to, we're gonna use the Gemini. So chat Google generative AI, inside this we're gonna use the model name. So for this you can use any model, that is the Gemini Pro model also. If you go to the AI Studio, so let me go to the Google AI Studio, let me close this. So if you click on create prompt, you can see that there are lots of models available out there if you select the model option. So if you click on get code, so let me close this and let's try to change the model. You can see that there are lots of models available out there. You can choose any one of these. In this video, I'm gonna choose Gemini 2.0 Flash. Here you can see if you click on get code, we have the model name. Let me copy this model name and let's go to our resource view code and let's paste that model now. This is the latest model. So instead of using the Gemini Pro model, I'm going to use this model. Now we have the LLM that defined. We can invoke the LLM. So LLM dot invoke. Invoke means just call the Gemini. So that's it. So LLM dot invoke. Inside it, just pass the input query. That is input prompt. Now we have the result. So we can just print the result. So that's it. Result dot content. So that's it. If you count the number of lines that we use in this video, you can see that it is actually, I have only used the 12 lines of code other than the impose if we exclude the impose. So let's try to copy this Spark and let me go to the terminal and run it now. So let me clear the screen and I'm gonna run the file now. So we get a error like Langchain community is not located. So we'll have to install it also. I forgot to install in the earlier part of the video. So let me copy this command and let's clear the terminal to install this now. Langchain community, we need this. We consider now Langchain community has been successfully installed. Let me clear the screen now. Let's try to run this one more time. So we get here warnings like we are using the older versions of the Langchain. So we can ignore that safely. You consider it downloading all the necessary things that we need for this uh, project. You consider it is downloading the embeddings, tokenizer, special tokens, and finally we get a prompt like enter the query. Here you can ask the query now. For the query, I'm gonna ask. Let me go to the PDF now. So first, we can ask a question like what is automated grading? So let me go to the terminal and ask what is automated grading here and press enter. Let's see if it is giving the accurate answer. So we get here like authentication failed. So let me check it. So if you go to the research report, we forgot to pass the API key, right? So this is my fault. We'll have to pass the API key here. So API key equal to, let's pass our API key. So now this should work. We have passed the API key now. Let me go to the terminal and let's try to run this one more time. Before that, let's clean this up and let's try to run this one more time. And for the prompt, I'm gonna ask like, what is automated grading? Let's type the prompt now. What is automated grading? And press enter. You consider now we got the answer. Automated grading is an efficient and automated approach to grading handwritten answer sheet. It uses the OCR technology to text extraction and the LLP models for a semantic understanding. This is what we have in the research paper also. So if you go to my research paper, here you can see this is the same thing that we have used. Automated grading means using the LLM and the OCR technology to automatically evaluate the handwritten text. So let's try to run this one more time and ask a different question. So next I'm gonna ask what is the methodology used in this report. So the methodology we're gonna use in this video, that is the OCR based answer extraction, right? And the next one is the question answer mapping. First we have the OCR based answer extraction, then we have the question answer mapping, and finally we're gonna use the NLP to evaluate the answer sheet. And once we evaluate, we're gonna assign the grading. And the cool part here is that it will return us the answer in a markdown format. And if you use any online markdown compiler, you will get the response in a nicely structured format. Let me show you what it means. So let's go to the online markdown compiler now. So let me open the online markdown compiler and let's open this compiler now. So if you go to the terminal and if you copy all the result that we have, so let me copy this and let's paste the markdown here. You can see that now we got the output in a nicely structured format that you see on the preview. You can see that we got the result in a bullet format and each heading is highlighted here. You can see that each heading is in the bullet for bold text. So this is the power of using the Gemini. It will return us the answer in a markdown format, and you can use the any online markdown compiler to get the result in a nicely structured format. Let's go to the terminal again. LLP based answer evaluation, we have used the both llamas and GPT models. If you go to the report, you can see that we have done the same in the uh, report also. OCR based answer extraction, question answer mapping, LLP based answer evaluation, and in the LLP section you can see that we have used the both GPT and llama models. This is the same thing that we got in the terminal also. And let's try to ask one more question. I'm gonna ask what is the specification that we need to build this project. So let me open the terminal and ask the question. What are the specifications that we need for this project? So let me clear the screen and ask what are the specifications that we need. And let's type the prompt now. You can see that we get the response. We need processor, RAM, storage, operating system, Ubuntu. This is the same thing that we have in the PDF report also. In the PDF report also we have the processor Intel i7. And finally, I'm gonna ask what are the challenges that we need to overcome to build this project. In the challenges section, we have the OCR accuracy issues. Let's go to the terminal and ask this question. What are the challenges that we need to overcome to build this automated grading system? Let me type the prompt now. What are the challenges that we need to overcome in this project so that we can build this successfully? You consider there are several problems listed here. The first problem is the difficulty in accurately interpreting the long and complex answers. So if you go to the documentation, You consider poor handwriting, ill eligible text, difficulty in accurately interpreting long and complex answers with multiple ideas. This is the same thing that we got on the result also, difficulty in accurately interpreting long and complex answers. So yeah, so this is how you build a chat PDF in less than, actually we have used the 12 line, right? So for now we can say we use less than 15 lines of code. So this is how you build a chat PDF in less than 15 lines of code, and we will get the result in a markdown format, and we can do the same for this also. Let me copy this text here. Let me go to the markdown compiler and let me remove this and paste it here. You can see that we will get the result in a nicely structured bullet format. This is how you build a chat PDF using the Gemini API and using the Python. So this is for this video, and I will continue in the next one.